Yesterday, we saw a very impressive large tornado outside Morton, Texas. This is near Lubbock, and this was a setup I didn't make a video for beforehand, but I wanted to go over the video. This is credited to Greg Robin again on K Houston here. But again, there's a very large tornado going on. There's a lot of pictures of this thing. This is a very cyclical tornado producing supercell, and the radar imagery is very impressive with this storm as well. Looking at this imagery online on X, I found this just on Google, but you can see the very impressive looking imagery for this tornado. So I want to go over some of the setup for this day, and you can see very well here two enhanced risks. I actually did a lot like the forecast I made this morning, but you have these two enhanced risks, both kind of for hail, but we also had that 5% tornado underneath them as well. So I want to look at what was our environment, what caused this tornado, and just looking at the radar loop of this thing. First, I want to look at our environment. I always find it easiest to look at environments by going back to our model runs of the morning. It's what I'm most comfortable with, but it helps show what you would look at on the forecast and what you're going to expect rather than what actually happened. This isn't as much of a case study, but more of a what happened in this event. Let's look at our 500 millibar map here. I was looking at that a second ago, but 500 millibars is almost always where I want to go if I want to know what's happening in our atmosphere. So this was the morning of 9Z before you really had much to look at. Overall, you see a pretty decent ridge down here, kind of over Mexico right here. This is leading some flow up here, and overall a general troughing feature out here, with the main trough being out towards Canada, but we do still have a little bit of that upper level low here, helping to create this area of enhanced flow right here. You can see this by our colors. It's not very incredible for 500 millibars. Usually we see more of the yellows, something like this for our severe weather setups. More shear is helpful for severe weather, but we did get kind of this ring of fire, as they tend to call it. You can see a little bit of a little minor jet streak here. The jet stream as a whole was not super favorable. You can see 250 millibars is our upper level winds. Again, not super impressive overall. We do have that slight maximum in our region of interest. Again, this being Texas here, New Mexico is here. See our state boundaries here, Colorado, but New Mexico out here. And that is where our jet stream was going. Looking down 700 millibars, looking for any shortwaves of interest. See definitely a bit of a shortwave trough more up here, but that's kind of removed from our area of interest. We still do have a little bit of that flow, but again, we're kind of struggling. And the main reason you can see where we get our storms is when we looked at 850 millibars. Again, morning of here, you do have a little bit of that low-level jet. This will decrease with into the morning because typically it is strongest right after dark due to thermodynamic laws. But here you'll see this is 2022Z, so about 5 p.m. Central, and watch how quickly this is ramping up. So if you've 21Z, that's 4 p.m. You're seeing this increase in colors. You're seeing that increase in winds. It's extremely quickly after dark there as well. Just watch how quickly this lights up there. And you get this low level jet increase. In particular, though, just the fact this is increasing throughout the day indicates lowering pressures, as well as just a strengthening environment for supercells, or really just any storms that are able to take advantage of low-level rotations. Finally, I want to look at our surface response. Let me zoom in here to our Southern Great Plains sector, because you remember our cell did form on a path somewhere to back color, somewhere right here in this vicinity, basically right there. So just watch how our environment is improving throughout the day here. Here's the morning of. We have winds out of the east here, kind of warmer air, so maybe a little bit of a frontal boundary in there. Moisture, not the best, and you can kind of imagine Lubbock somewhere around here. Lubbock should be right in here. You can imagine not very good moisture, but throughout the day we do see that increase and better moisture content right here. It's kind of 70s going on right in the vicinity of that where we saw our storm. So we do get this moisture return. Looking at our winds, just our pure temperature here. Again, we have our wind barbs here. Looking at our pressure, again, we begin here at about 1010 millibars, and throughout the day here we do see these height falls. So at 0Z, so that's about 15 hours out, you have 4 millibars drop of pressure. So you do see that pressure tendency lowering throughout the day there, and that helps storm development. Again, storms like to be in that area of low pressure. Also notice how winds increase with time here. You do get winds out of the south, and that, again, as we said, that's that moisture moving in. We get the winds out of the south, but also a little bit of the southeast. And if you remember, that's often helpful for tornadoes, especially with those low-level photographs. If you remember, typically you want your curve to look something like this. Having the winds out of the southeast is very helpful for that. If you kind of imagine like this is your 0 point, typical photograph for supercells, tornadic is more like this. And you have winds more out of the southeast or just easterly component at all. And because we have this easterly component, that was something that would be aiding in tornado development if we were able to get it. Theta E is a measurement of instability, and you can see here definitely lighting up in that region of interest here. Really just overall lots of instability throughout that day. And speaking of instability, let's look at real CAPE here. Here's a surface-based CAPE, again, 9Z, you don't have anything at the morning hours, but very quickly you get this instability going in. Definitely this quick area of instability, upwards of 3,500 joules per kilogram, increasing throughout the day there, but you get this very large area of instability, basically right in the panhandle, right where we expected to see storms. And most unstable CAPE, this was basically as much CAPE as you could get, was through the surface-based storms, so this wasn't really as much of elevated convection. 3 CAPE, that's our lower level instability. It's often very helpful for tornado producers. You can see that this definitely was prevalent in New Mexico, but didn't really remain in our area, or in the area of interest for as long as would be expected. But you do still get this very, very large area of instability that remained. I might take a check at meso-analysis to see how that evolved with time as well. Low-level lapse rates, again, pretty solid. Better low-level lapse rates than we'll see typically in the Midwest. Mid-level lapse rates, similar story. We do have some observed soundings we want to look at. Get rid of them. So I'll show you how to find observed soundings then. Put it there. So observed soundings, this is just SPC site for convective outlooks. I want to show these soundings that I have. Go down here to forecast tools. Observed sounding analysis. This only works for about a week. As close as you are, but this is close enough timing here. So this is June 5th. That's when we had our tornado. We get 20Z here because it's just when I found it. But you have 3 soundings here. Let's look at our Amarillo sounding here. Again, look at our photograph. We get that lower level shear. Not super impressive. We're still out of the south, kind of southwest here. It's not really the easterly component. We do still have that curvature in the low levels of the photograph. Looking at 850 millibars, not super impressive low level jet at this point, but do remember that was increasing with time. Instability, not super impressive either, 2,700 joules per kilogram. But overall, that is still that's still beneficial for storm development. There's no cap in place here. Very moist profile, basically very far up as well. In particular, though, we have essentially complete saturation all the way up here to about 700 millibars. And even though we are in the higher plains here, do remember that is quite a bit of saturation, over a kilometer up in the atmosphere. So it's still pretty impressive overall. Looking at just other areas of the risk area here, here is more north in Dodge City. Not as impressive profile here. You have your little bit of an inverted V there. Not the best moisture near the surface. Photograph still something to be desired in there. Had that warm air advection too, but overall not much instability to work with. That's very different in our Amarillo sounding. Lots of warm air advection. Not impressive warm air advection, but some throughout most of the profile, and a good amount of instability to work with. Not too much instability though sometimes, and that can help damage storms. Also something to note, look how generally straight this photograph is as well. You do have a little bit of that curvature. For the most part, lots of your profile stays relatively straight with time here. If you remember, a lot of the times we have these straight photographs, we can get splitters. Notice our right mover vector and our left mover vector. Because straight photographs help, it's a lot of math. A lot of it I honestly don't understand either. But when we get these straight photographs, you end up with 2 supercells. One will produce more hail-based, more hail, heavier downdrafts, maybe anticyclonic. And the other one will move on down to the right, and that will be more of a tornadic cell. And these straight photographs will really help for splitting. Lastly, I want to look a little more south here. You can see with further down south we went. Don't know what station ID this is, but you can see how much more incredible this instability was, but not nearly as surface-based as Amarillo was. This is 20Z. Our storm was basically forming right about 21Z if we go through the radar loop in a second. But we had our storm really going around 23Z. So if you can imagine, this is our pre-storm environment. Instability likely to still increase a little bit, but overall good environment for these storms to move into. Lots of instability more to the south as well. but still more of the inverted V. So this Amarillo location was basically kind of the perfect sweet spot. You have the instability, you have the moisture, but you don't have too much heat. And more south here, again, temperatures are more near 89. Amarillo was remaining at 71, but still moist throughout the profile. So let's look at our satellite imagery. We do have satellite imagery because we are close enough to this event. So we went back the time here, and let's just start here right at 18Z. So notice early on, again, we still have this, we have a large area of basically stratus, it looks like, out ahead. I'm unsure, I can try to go back a little bit further. Let's go back, yeah, we'll go back further to see how the morning was looking. Take a second for this satellite loop to load. But looking back to the morning, overall, we see the morning, lots of stratus overall, good amount of cloud cover, maybe fog in there as well. This is, kind of helping to keep temperatures cooler, just having a lot of cloud cover like this. Watch as that erodes with time. Not super impressively, but you do get this area, stratus deck, but you do get an area of bubbly cumulus to the south. Again, we looked at our profiles here, much more instability in our southern location. Actually, I'll even go back. Let's go back to our 12C soundings and see what those looked like. Here's our first, here's the first sounding. The same location we saw a lot of instability in. And this location, we have a lot more instability going on, a little bit of a capping in place, but overall instability right as the morning begins. Let's see if we have any other soundings. Doesn't look like it. Closest we have is this station in Oklahoma, but we do have that, again, a lot more instability in the morning hours. You notice how we see all this bubbly cumulus really quickly form. You can get storms here along the dry line pretty early on in the day. Well, this isn't that early on, but this is about afternoon, right about 1 p.m., 2 p.m. here. Very quick storm development down here with that increased instability. But you notice just in this region, a general cumulus field going on. That is indicating that, again, we have that instability in place. If we remember our service features we looked at over here, we had a little bit of a dry line, pretty clear out here in New Mexico, actually. So we had a bit of a dry line going on out there. And while moisture didn't, overspread the region completely, we did have a little of that moisture remaining out there in New Mexico for storms to form off of. Watch that dry line. We do get also this kind of a bit of a boundary here. This is very interesting in particular. Let's look at our radar here. I hadn't noticed this before. This could have been some outflow from the storms the night before. So let's look at our radar loop from the night before the event. Notice a lot of kind of this squall line going on. A lot of this cold air here, you can see it remains in the overnight hours into the morning. But notice this little line right here. That's a lot of that cold outflow. So that was leading to kind of an unfavorable region up here for a while. But also outflow boundaries are often something that storms can latch onto and basically use as a forcing mechanism. So do keep that in mind. And as we notice here, with this bubbly cumulus, but you do get some storms developing along the outflow boundary in this moisture-rich area. Then quickly you see this very large overshooting top here, and this is our storm of interest. This is our supercell. We'll need to look at the radar to see more of the details here, but you get this storm development very rapid, quick anviling. You can notice we have one storm up here, one storm down here. These merge together here. Watch as they combine into one anvil, very strong. And put our warnings on here as well. And 2 cells, and then immediately both are tornadic once they combine. And here's our supercell right mover, very, very clearly here down to the southeast. So they have a right moving supercell, and that was what produced our tornadoes here. So let's look at our actual radar now instead of just our satellite. Again, we're going to see a very similar story here. We're at our Lubbock radar. This was yesterday at, I took the radar loop from 7 p.m. This is at 4:30. You can even see some ripples out here, which is very interesting. Maybe some horizontal kind of active rolls here. So notice we have these 2 cells we looked at. One strong storm here ongoing. One down to the south that was getting its act together. Watch quickly how that one just really explodes with time. And these will merge together. So notice our 2 storms here. One's near Portales, I believe that's New Mexico, and one near Clovis, New Mexico, excuse me. Other one near either Caussy or Dora out here. And these will combine together right here. Notice 2 rotating updrafts as well. For radars down here, this is this is cyclonic rotation here. We don't really have a rotation on our southern cell as of that moment. But you'll notice we did immediately get this hook out here near Cossie. Potentially even re-signature here. Actually, I might take a look at that. Actually, yeah, I'm curious. Let's take a look at correlation coefficient. That could be a confirmed tornado at that point. That would be very interesting. I don't want to mess up my radar loop too much. I messed up my radar loop. That's okay. We do get the maybe possibly a debris ball in there. I'm not 100% certain on that, to be honest with you. Okay, move forward with time there. So yeah, we get that hook very clear, and immediately we get kind of a merger here. We see the northern cell die out very quickly, but then the southern one really strengthens quickly here. We get a hail core pretty clear, but very quick strengthening for this southern supercell. And likely due to the storms kind of combining, from what I can understand, it looks like updrafts combined, especially based on our satellite. Very clearly here we get a right mover cell. Not to mention we also get kind of a southern cell down here that also merges. Notice how we have, I'll be clicking through this radar loop a lot. Notice these little showery activities out here. Basically right here in this region. Actually, let me use radar scopes for this because it's very useful to see both. Have some shower activity on here on both. We'll look through here on the radar before the time here. Notice these showers, they move off to the northeast ahead of the forward flank downdraft of this supercell. And you get this strong downdraft right here. You see it on the red. Quickly, this actually gets a little bit of a mesocyclone. This will combine into the forward flank and the storm as a whole into kind of this large area of potential downdrafts. Again, this still has that rotational signature. This is an embedded supercell right in here. Let me draw it. I have kind of this embedded supercell in here, very small, and it has that little hook appendage, and that right there you can see on the velocity we do have that rotation right where you'd kind of expect it. So move forward time a little bit more, and then watch how quickly this one strengthens. Very quickly, you get this big surge of downdraft. Again, probably due to all these storms combining. Very quickly, just watch our downdraft here. Watch our greens. That's our downdrafts. That's our rear flank downdraft. Watch how quickly this just strengthens. Really rapidly. You get that very clear hook here. Very much removed from the forward flank precipitation, and very quickly here, very intense mesocyclone. This is within a span of 5 minutes. If you go from here, this is 10 minutes. This is our kind of broad rotation. And within 10 minutes, you have an extremely tight mesocyclone, very intense. I think at this point there was a radar observed tornado, and look at that. Look at that huge uptick with time here. Just an incredible rapid intensification of a supercell. Just due to our storm mergers. Again, just watch this one more time here. Watch how we have our storms up to the north. Kind of just multiple congealing cells together here. Even some on the backside here probably also aided in this tornado genesis. Let's see if no, but definitely these storms up to the north. That was our main aid. Was that one cell gets very intense, and then the downdraft just really intensifies with time there, and that's kind of how we end up with this large wedge tornado. Before the time here, we do get shower activity, so basically rain wrapping this storm. Even again here, very intense couplet. This is gate to gate shear here. Really just not even be folding here. It's just so intense. Gate to gate shear is about 170 miles per hour. This couplet was very intense. Just a very incredible couplet going on there. Even for the time here, and eventually you'll see we do get this destructive interference and mergers with these two cells ahead of it. Very quickly you see just that mesocyclone dies with time and just decreases in intensity. And this would move on down to the southeast, and I believe it might produce a few more tornadoes if I remember correctly. This is a very cyclic supercell, and you can just watch as that tornado just really wrapped up outside Morton. I mean, you can see it on. This is just incredible radar imagery here. You just see the cells ahead of it about to affect the tornado, and basically what we looked at here. And there is something to be said again. We look at the gate to gate shear, but there's very much a possibility that we are just looking so high up in this atmosphere here. Don't forget that radars go upward with height. Our beam height out here was 4.4 thousand feet up, which isn't our lower level, so that's basically just measuring a mesocyclone at that point. But the fact that this mesocyclone intensified so quickly is kind of showing what was going to be happening in our low levels. We didn't have a very intense mesocyclone before we had all this mergers here, and very quickly we just see this uptick in velocity. Very impressive. That's the general story of this storm. You'll notice on our I had it here. The storm basically died out once it hit basically near Lubbock here. So I believe this kept tornadic characteristics for a while, if I remember correctly. Looking at our satellite loop here. Let's look at our satellite loop. Go back to there we are. And looking at our warnings here, we had tornado warnings remain all the way into basically right after about 8:30. It looks like our last tornado warning happened here. And this is the tornado warning we looked at, was right at this frame essentially. We had that tornado warning going on with that ongoing big wedge tornado. So yeah, so hopefully and I think that's the most I can go through with this. You can look at meso analysis, I suppose. That might be a future kind of case study. But I just want to look at this tornado again. If I think it was really interesting just to look through, and just the radar loop of this thing. Really impressive. Just watching how these two storms just kind of combine. You get aid from the back storm. One storm forms up here, and then immediately rapid intensification of the mesocyclone before more storm mergers affect everything. That's kind of how this ends up working. Straight photographs lead to kind of a mess, lots of storm mergers, but we saw this one right mover just go on its own. Maybe not even a right mover. It's very interesting how you just notice the path of this supercell change right here. Get out of the southwest, very clearly out of the southwest here. When we get some of this downdraft from the storm above it, it takes on this right mover and continues to move on to the southeast here, possibly forming a left mover up here at some point as well. So just a really interesting storm to look at. I believe it stayed in fields as well, which is even better. So there's lots of storm chaser coverage on this tornado if you're more interested. So with that, I'll leave it there. Again, if you've enjoyed this kind of more technical analysis, please let me know. Any questions or anything, I'm glad to answer. And I had a lot of fun looking at this tornado actually. So but that's it for this video. So thank you all for watching. I'll see you all next time.